Alright, so yet again I ran out of video space on my phone, but I made some more. Alright, while it's gone, I put these screws back in here. They're pretty hard to get in there actually because there's only really one spot I can fit into. That's to ensure that your LED stays centered inside of your reflector. If it's not centered, it will make your beam not only not as bright, but it'll also give you a what they call a defect in your beam. So you want to have it centered and focused, and the focus is typically going to be set by your centering ring here. You'll see that this is thick. It's not, it's not really particularly thick, but it is not perfectly flat. So there is some thickness to it, and that'll actually lift your reflector off of the heat sink so that you have some focusing there. I may have to add to this one. I actually did have to add to it on my TN31 when I modified it. I did that with Captain tape. I don't have it out right now, but if I have to use it, I'll pull it out. Captain tape's pretty handy. It has high electrical resistance, good thermal conductivity, and it's very thin, so you don't have to worry about it being, getting in the way a lot. I actually have my batteries fully charged now. I use the SoShine 3400 milliamps. They were on sale on the Illumination Supply website. They come with a nice little carrying box, although I'm going to have mine in my actual flashlight. And then we have the actual Supbeam box here, and the Supbeam box does come with a little carrying spot for 3 batteries. So if you want to carry 3 extra batteries, comes with a case too, and a lanyard, and an extra O-ring, and a button. But if you want to carry some extra batteries in there, it's a good place to keep it. This is a real nice box. It's nicer than the one you get with the through night. I can show it to you real quick. This is the TN31's box right here. It's got a little plastic. This one's plastic still, but it looks better. This one does not have a holding spot for your batteries. But other than that, they're about the same. So, and the through night is again a little bit larger flashlight. It does go a little further, and they do drive it a little harder, I'm pretty sure. Alright. Now I'm going to hop right to it. I showed you de-doming the LED. I showed you putting this back in there and getting the thermal paste. Now what we're going to do is we're going to change these sense resistors out right here. They're really poorly soldered on there. It's going to be hard to see. I noticed by reviewing the last video that it's kind of difficult to get some of the smaller components to focus in on the iPhone there. I should have used my other phone or my other camera, but that's okay. It'll be fine for this purpose. The sense resistors are the 2 resistors that are closest to the spring. You're going to find these resistors on most drivers that use multiple cells in series. These are actually hooked up in series. So this is 3.6 to 4.2 volt 18650 batteries in series. So you're dealing with, somewhere in the 9 volts to at the low end to your higher end being above 12 volts. So you're going to have these sense resistors in there, and that's what we're going to change out, and that's going to cause our current to go up. You can also use low internal resistance batteries. I may have explained this already. These are also based on the NCR 18650B cell, so these are pretty much the same thing. They are relatively high internal resistance. They are not IMR cells. You may have seen those. I don't think I have one sitting around here. Actually, I think I do. You've probably seen some on the internet that look something like this. It's an AW 18650. This little guy is low internal resistance, so it does put out a little bit higher amperage for a given setup. I'm not going to use low internal resistance batteries. I don't even know if I can, because I'm going to change these sense resistors out with such a low resistance sensor. These resistance, the resistance in these is actually 1/4 of the resistance there, and I never did calculate out the current. I'm going to hook it up when I'm done and test the current. I'll go get my meter now, and well, I'll do it when I'm done. So I'll actually hook it up and test the current to see how many amps I'm drawing. It should be around 6. That's what my theoretical current was based on what I calculated. So we'll get all this stuff out of the way. I'm kind of getting jumped up here. So here we go. Soldering iron's nice and hot again. Again, clean it off. Keep a clean tip. It's good advice for soldering. Keep a clean tip. Alright, we're going to add some solder to the tip here, and I know it's hard to see. These little sense resistors, the whole resistor is going to heat up enough to where I can just desolder the whole thing at the same time. Yeah, they just pop right off there. No problem there. I'm going to keep these just because these little sense resistors come in handy sometimes, so I'll keep them. You can get new resistors off of DigiKey or other websites like DigiKey, Mouser. The way we're going to select them is just you can look up this little guy. It says something on the front of it, RO 82 or something. It says something on it. It's just two of them. They're in parallel. Actually, I think they're actually wired in series right here. So I just got two resistors that I found to be 1/4 of the total value. Let me get them out here. They're really hard to handle because they're so small. I'll use my tweezers. Clean off the tip of my tweezers. I got some thermal compound on them earlier, and thermal compound is very sticky. Alright, let's clean up these little guys. I have a desoldering braid, which is something you may want to have too, and that I may want to use right here. I'm just going to clean my soldering tip off and get some of it off with a soldering tip. How you clean stuff up with a soldering tip is if it's the right temperature. You don't have it too hot. You can just take your solder tip, run it across there, and it'll pick up some of the solder. Just from, it's going to be the cohesive, actually it's going to be the adhesive properties of the solder. Going to cause it to, I'm going to go ahead and get my braid. I'll show that to you. There's another room just across the hall there that I keep most of my stuff in. So here's my braid, and I can just heat up the braid right above the point that I want to remove the solder at. And then it's going to take pretty much all that solder off. It gets entrapped in the braid itself. And then you can get this just about anywhere, like a Radio Shack or any place like that. We'll have desolder braiding here. Once I get finished removing the old solder, I'm actually going to put some new solder on there. And this is really micro soldering, which is kind of difficult to do. It's such a large soldering iron, you know. Like I said, if you want to get a better soldering iron, it's better to do it when you first get started. Not when you've been doing it a while, like I said. I could probably use one, but I don't really care that much anymore, so. Alright. You can't see this at all, but what I'm doing is I'm applying heat to the actual solder pad there, and then I'm going to stick the solder directly to the pad. It's going to apply some solder to the area there. And then what you do is you take your little resistor there, you apply it to the pad. Yeah, these are really small. Really difficult to do this with, but you line it up. And then you can put your heat directly to the top of the resistor, and it should go in there just fine. You want to kind of try and line it up. Your guess is as good as mine what the best way to do this is. I don't really know. You saw me almost touch my soldering iron right there. That's going to happen at some point. You're going to touch your soldering iron. Can't help it. It's just human nature to try and touch stuff that you shouldn't touch. So you'll mess around and touch it at some point. It burns. You get over it pretty quickly though. Alright. Let me get this other sense resistor in there. And the little resistors are going to tend to touch You're gonna tend to stick to your soldering tip. It's annoying. But there you go. That one went in a little better than the first one did. Let's see if I can move that first one over a little bit. Oh man, I moved it in the wrong direction. Alright, there we go. Okay, there we go. So they're all soldered in there. It doesn't have to be pretty, it's going to be covered up. So I'm not too worried about it. They are soldered, they are a good soldering point. I'll go ahead and get my multimeter now, and what I'll do is I'll compare, if I can find it, the stock one versus the new one. It's my multimeter. You might not have ever seen one like this. It's a TAC-T or unit. I got it off of bx.com. I think it was like $50 something. I use a nice fluke meter at work. Costs like $500 something. This will do every bit of what the fluke will do and more. So this, I've got it set on resistance, which is the omega symbol. I'm just going to test. It's not hot, so we'll go ahead and test the resistance of each one of these. It says 0.2 ohms, and I've got 0.1 ohm resistors, so they are series. Let me get the stock one. 0.3. So I didn't go as low as I thought I did. 0.2 and 0.3. So it's going to be a jump in current, but it's not going to be terrible. So we'll put this over here. I should probably test mine. I should go ahead and try and take apart my TN31. I'll test what its resistance is. Let's make sure this is all done the same. I was pretty sure they were. One-quarter, but maybe not. Maybe I did 3/4. Then again, I don't remember the calculation that I did to get there to the 6 amp point, but tested it all out. Alright, so we're going to check right here. Same thing, sense resistors. They're in the same spot. This is pretty much the same exact driver. Oh. Alright, what's resistance here? 0.2. So, same resistance. Same resistance here. Okay, good. Alright, that's good. Alright, and then I'm going to switch this over to 10 amps right here. This little labeled as 10 amps. That's going to give me my current whenever I get ready to go for it. And I got some little clips I'll use for that. Actually, I've just got the one clip I'm going to use for that. I have two, but I'm not going to use the other one. Make sure you always check before you go and short electricity that you're not in this 10 amp internal. It's just got a little fuse in there. It's internally fused. If you're over here, this is safe with if it's in the hertz volt. But when you're over here in the amps or milliamps, and you mess around and try to test 120 or 240 or 480 volts between there, bad day. So don't do that. Just make a big spark and it'll scare you, but you should still be fine. These grips are insulated. Okay, so here we go. I'm gonna now take the driver. I'm gonna stick it in here. You gotta run these two leads on either side through the holes. Gotta make sure you get the positive on the correct side, which is going to be my top side, which is the red. Let's make sure. Yep, LED positive, it's labeled. Here it goes. It's kind of weird that these Chinese companies use American writing, or English writing on their boards. They don't really have a whole lot of Chinese writing on their boards. Maybe due to symbols being too intricate. be able to see it really properly. Alright, you have to make sure that you spin it in there correctly, because these magnetic reed switches that we use right here, they won't necessarily work if they're in the wrong spot. So you'll get like modes that don't work if you stick it in there wrong. Then you need to line the holes for the screws. Alright, I'm going to use my tweezers again. They come in very handy. And I'm going to use them to pull my leads. My lead up here. It's not wanting to come. It got a little bit of Arctic silver on there whenever I pulled it through, and these grips. These are not a very good grip, so I don't normally use them to really grab stuff as much as I do to torque stuff down, which causes them to get a little bit off. All right. Anyway, I'm stopping muttering to myself now, and I'm gonna screw this into place. You put your piece of metal back on there, your little piece of aluminum, this conductor. This little piece of plastic is not wanting to cooperate with me. What it does is it just isolates your positive and from your negative. So make sure you put it in there, but it is pretty annoying. Alright, we'll just get this spun around. You gotta align both sets of holes. I think that'll do it right there. Nope, not quite gonna do it. Alright, we're gonna have to try again. I'll leave this in there just to show you how difficult it is sometimes to get these aligned. And now that you pull it out, you're going to have to put your wires back in there. So I'm just cleaning off the Arctic silver off of the wires. It is very slippery. And sometimes you want to check on your soldering points to make sure they're good too. Like I said, that one mode did not work on that other one because it had a broken MOSFET or an electrical component in there. Again, check which side's positive. You'll kick yourself if you don't. Positive, this side right here. And check your alignment. Get it all nice and aligned. There it is. Alright, then you want to take this little guy, put it in there, and then again align them up, get your little screw. These are pretty annoying, they're very small. I didn't use a magnetic tip for this. The way I did is I just kind of sat it in there and then pushed it into the hole. Rhianon. 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 My wife's not in there.